Hello everyone, my name is Tushar Ghosh and our topic is lecture video summarization. She is our guide, Dr. Umadi. She has been of wonderful help throughout the project by suggesting us good ideas and identifying the flaws in our system. Here are our team members, me, Durjoy, Rishabh, Surabhi and Shreya. So, video summarization is the process of converting a raw video into a more compact form like a video, audio, text or slides, which will be of importance to the user by not losing any information. Nowadays, there are abundance of lecture videos online, and lecture videos tend to be long in nature. If a user wants to go and learn a topic, he or she has to go through the whole video, and that can be very time consuming. We have tried to make it easier for students by summarizing the video in the form of slides, along with the key points taught so that the students can go through them if they want an explanation of the topic. With the help of shot detection, we are taking a screenshot of the lecture right before there's a drastic change in the lecture. We have tried this method on short videos as well as long videos and have received good results. We have also included a search engine for topic-based searching of slides or video clips. So these are the team roles and responsibilities taken by our four members. So here is a summary of the requirements of our system. So short detection are done on video inputs. We accept the video of any length. There is a key phrase extraction, which is one of the main methods in our system. So a few things we have assumed are that the lecture video is in English. The audio must be clear for good accuracy of audio to speech, speech to text conversion. There's an active internet connection and the user has a web browser. Some of the risks which include is the system might miss out on some of the salient topics which might be important to the user, but the accuracy of our system is pretty good in that respect. So we have introduced a total of 6 modules. The first module is splitting the video. So we split the video in a manner so we try to separate the subtopics in a lecture. Shot detection is done using OpenCV by a method called scoring. So shot detection helps us in detecting when the camera focus changes from the professor to slides. This indicates as the change in slides and hence the change in subtopic. The next method is extracting the images. During the lecture, the professor generally designs their slides in such a way that each point in the slide appears one by one as they speak. From each video split, we extract the last image from that split, and that becomes the slide of our system. We extract the audio from the video splits, which we have done in the first step. And in the next step, we do a speech to text. This is done using Google API. We need the text so that we can generate the keywords associated with the slide. In this step, that is the text to key phrases, we try to extract the key phrases. We do this by using the n-gram model. This is done. Before that, we remove the stop words and all the special characters. And the final step is the slideshow summary. Here what is done is all the images that have been extracted in the first step and the key phrases that have been extracted in the previous step are merged together, which becomes the final output of our system. So this is a diagram of how our system works. So the final step is slideshow summary. The slides from the lecture will be an ordered sequence of the images extracted from each of the video splits along with the key phrases. In the first step we split the video. In the second step we extract the images. In the third step we extract the audio. In the fourth step we do a speech to text translation. In the fifth step we identify the keywords and summary using the n-gram model. So this is a masterclass diagram. It tells us about all the steps that we do. It has been already described in the previous slides. So here are the modules which have been also described before. Some of the tools and APIs we have used are Python, Google API, OpenCV, FFmpeg, XAMPP, and NumPy. These have been used to do several tasks like audio to text conversion, which is done by Google API. We have done shot detection using OpenCV, and splitting of video is done using FFmpeg. So this is how our user interface looks like. On the left, we can see what our slide looks like. We have the previous and the next slide option. On the right, we have shown the important data points or the keywords that are related to the slide. If we want to view the corresponding video clip, we can do it on the right. We can also view the full video lecture, that is the option on the bottom right. This code shows us how we split the video into smaller chunks, and these are the video splits. This code tells us how we identify the last frame of the video, which will actually be our slide. We convert a JSON text file, which is the output of our Google API call, into a raw text file for our use. So I'll give a demo of how our website looks like. So this is the landing page of our website. We have summarized a video which is of length 51 minutes. So this video is by MIT OpenCourseware. The topic is Introduction to Machine Learning. This is the free to use video. So for this particular video, we have generated a total of 103 slides. The keywords which have been detected in this video are supervised learning, training examples, machine learning, label data, clustering, performance metric, etc. So we can go to the next slide using the next slide option. And as you can see on the right, we can see that there are a total of 5 keywords which are being talked about in this particular slide. If you want to view the corresponding video clip, we can click here.
So as always,
So this is a 20-second video clip where the professor talks about topics like robotics, computer vision, etc. Here we can view the full lecture if the user wants to. As I have already said, this is a 51-minute 30-second lecture. The final and the most important feature of our system is the search option. The search option gives us users the option to search for specific keywords and identify where it has been taught in the whole video. For example, if I search clustering, you see clustering has not been talked about in this video. For example, if you talk about features, we can see that features have been talked about in a total of 6 video clips. So we have already talked about how all these features work. So basically we have the previous and next options. We have the option of viewing the full video. We can view the particular video clip. We have the keyword search option. I just searched the keyword features and we could see that there are a total of 6 slides which came up. So basically we have designed a website that helps users summarize their lecture videos in the form of slides. Yeah, we have also made sure to attach the clip associated with the slide, so if the students want an explanation about the topic, they don't need to go through the entire lecture. And our final and the most important feature is the search option, which saves ample time and effort of the user. We can say that the accuracy of our individual component of our system is good, however there is a huge scope for improvement. We can execute these components sequentially, so the overall accuracy might fall down as the errors of each component get carried forward and affect the next components. What we have decided for our future work is to improve the user experience and increase the overall accuracy, and develop ways to cover up the errors getting carried forward from the previous experience. Thank you, that is all from our side.